And finish 8.3. We're dealing with, again, dealing with some division here. So I'm going to take that example and I'm already going to write it as 9 over 3 for my exponent on x and y to the 13 over 3. Again, we're dealing with like division and kind of whole numbers and fractions. So 9 over 3 comes out to just be x cubed. That's great. But 13 over 3 doesn't work out nicely. There are 4 3's inside of 13, and we've got a remainder of 1. All right, so that leads me to the fact that I'm going to be able to write my answer as x cubed, y to the 4th. Those were all the whole numbers that pop out, but we're still left with a cube root, a third root of a single y. All right. Up next, let's see what happens here. We've got 64 to the 5th root. My question is, does that root nicely? I think it might. So 1/5. Oops, 1/5. It does not. Interesting. So 64 is going to have kind of some of that behavior of like the y's that we saw before. Okay, so what can we break 64 down into? How far can we deal with that? Well, let's see here. 64, it's kind of special. We can break it down into 2, 2, 2, 2, 2. Evidently, 64 is just a bunch of 2's multiplying together. Interesting. And if you kind of tracked that division I was doing, it turns out that 64 is 6 2's multiplying together perfectly. So you're going to need to do what we sometimes refer to as prime factorization. That means we break 64 down into its smallest parts, or its prime factors. So 64, yeah, that's 8 times 8, but 8 can still break down further into 4 times 2, or in other words, 2 times 2 times 2. So that's the idea. Break that number down into its smallest factors. It turns out that there are just 6 2's multiplying together to get you 64. Same idea, x is to the 16th, and we're now going to do the same things we did before. I've got 2 to the 6 over 5, and I've got x to the 16 over 5. I'm still interested in what these numbers are coming out to be. So 6 over 5 is, again, improper. There's a whole, or 1 5 can go into 6, but we'd be left with a remainder of 1. And that's what I'm interested in. I'm interested in when is this going to not have a remainder of 1 left over. It is going to happen at some point. Okay, so let's deal with all of our whole numbers. 2 to the 1st is just 2. That escaped. It was a whole number. X cubed is a whole number. And now I've got 2 things that did not escape. A single 2 and a single x. 2x cubed. And the 5th root of 2x. All right, we've got 2 more to do. We're going to kind of combine all of our rules here. Let's see what happens. The first thing I'm going to do is I'm going to say, well, there's some numbers outside of the root. Why don't I just multiply those outside of the root? Now I've got stuff left over inside the root, and that, of course, is 48. For the sake of time, I'm going to cheat a little bit. We've seen 48 a few times together. That's 16 times 3, but both of those numbers still live in a root because the 48 was in a root. And once again, that's going to be 15 times 4. 4 comes out cleanly. 3 does not. Well, 15 times 4, it turns out, is 60. So we've got 60 square root 3. And our last question here, of course, it's the worst we've seen so far, so let's deal with this. We've got a p on the outside, we've got an r squared on the outside, and now collectively in the root we can multiply these together. We've got a p cubed and a p to the 7th, and those exponents will add to make 10. We've got an r to the 4th and an r to the 7th, and those exponents will add to make an 11. So we've got a p, we've got an r squared, we've got a p to the 10 over 2, and an r to the 11 over 2. All right, and so we've got the p r squared. That's going to be p to the fifth. That came out cleanly. And we're going to have an r to the fifth, but a remainder of 1. When are these remainders of 1 going to stop? I bet in the next section. Okay, so putting it all together, a p and a p to the fifth will be p to the sixth. Those are the whole numbers that we got for our exponents. And an r squared and an r to the fifth will make an r to the seventh. And we've got a few things that did not escape the square root. Looks like just a single r this time. And that's 8.3. So good luck on that homework, and I'll see you in another video.